any of you who've worked with us in the past might have heard us talk about this 5-rope model that Liz has put on the screen. So it's based on the work that Kilpatrick and some colleagues have done, and it informs a lot of what we do at NRICH. So we want to start today by spending a couple of minutes talking about that, and then Liz will talk about how we've adapted this model to produce a child-friendly version of the rope model. So let me tell you a little bit about it. The idea is that successful mathematicians don't just show capabilities and fluency at conceptual understanding and carrying out standard procedures fluently. So if you look at the 5 threads of the rope, you can see that there is a middle rope, which is about conceptual understanding. So this is children understanding concepts, operations, relationships. And there is a thread on the right-hand side, which is all about procedural fluency. We want students to be able to carry out standard procedures fluently, efficiently, appropriately, flexibly. When NRICH started, there was a concern that too much attention was being given to these 2 threads and too little attention to other aspects that were very important for mathematical competence, for mathematical proficiency. Successful mathematicians are not just good at those 2 threads, they're also good at the other 3 threads. So let me just talk about them very quickly. Strategic competence is about sort of knowing what to do when you're faced with problems that you've never seen before. So having some strategies when you come across a problem that is new. So it might involve working from the particular to the general. It might be about trying some simple cases. It might be about working systematically. It might be about looking at different ways of representing, going from the numerical to the algebraic. It might be to do with conjecturing and testing out ideas. That feels like a really important aspect of being a successful mathematician. On the far left, we've got a thread which is all about reasoning. So we expect mathematicians to be able to engage in logical reasoning, explain what they're doing, justify what they're doing, sometimes prove that what they've done is correct and valid. Again, incredibly important for mathematicians. And then 1/5 strand, the productive disposition, which perhaps is one that informed our choice of becoming maths teachers in many cases. And this is sort of, in Kilpatrick's work, split up into 2. We want students to have a really positive attitude to the subject, to maths, to leave school, to leave our classrooms feeling really positive about the subject as being a useful, interesting subject that they're happy to engage with. But we also want them to leave our classrooms feeling really positive about their ability to make progress at the subject. Sort of what Carol Dweck talks about when she talks about a growth mindset. So those 5 strands together go towards building a strong rope. And you can see that what seems to be really important about this model is that all the 5 strands are working together, are complementing each other, and we don't have very thin threads that may fray and get sort of lost along the way. So ideally, when Liz and I are writing problems for NRICH, we're looking at problems where students can develop their sort of mathematical muscles in all of those 5 areas. And now Liz is going to talk a little bit about how we've adapted this model into something that may be more useful for you to use in your classrooms with your students.
Thank you, Charlie. Yes, so what we've done here at NRICH is use Kilpatrick's ideas and adapt it into something which we hope is slightly more student-friendly. So we've developed this new image alongside some new descriptors of each of the 5 key ingredients that we believe characterize successful mathematicians. You might hear us use the word ingredients. You might hear us use the word strand as we go through this webinar. We mean the same thing. So just to give you a little bit more detail about this student-friendly version, if we look on the right-hand side at the image you can see there, let's look first of all at the top left, that blue image, which is the circles connected by lines. This is representing a network. And here we're depicting the understanding, one of those 5 key ingredients. And we're suggesting that students come to the realization that maths is a network of linked ideas. We'd like them to be able to connect their new mathematical thinking to what they already know and understand. If we go around clockwise to the next icon there, which we hope you recognize as a toolbox in purple, this represents, obviously, the tools, which Charlie talked a little bit about earlier. So as students, we would like them to appreciate that they have a toolkit accessible to them where they can draw tools to help them solve problems. Practicing using those tools will help them become a better mathematician. And as Charlie alluded to, we feel that those first 2 key ingredients, the understanding and the tools, probably are well recognized by students working in mathematics classrooms. So as we move further around clockwise, we then come to the red image there, which perhaps you can recognize as one of those slidey puzzles. And this is representing problem solving. So we would like students to come to a realization that problem solving is an important, essential part of mathematics. So that they can use their understanding, skills and reasoning to help work towards solutions to problems. In particular, I think we're talking about a problem situation which really is a problem. They do not know how to proceed. What can they draw on in terms of their the knowledge and understanding they already have with their reasoning to help them proceed through the problem, to help them solve the problem. Looking then at the 4th image, which is our the cogs going round in blue. This represents reasoning. So we'd like students to understand that maths is logical, that they can convince themselves that their own thinking is correct, but also explain their reasoning to others. This idea that mathematics is it's not just out there for students to be filled with. They can work on developing that mathematics using their reasoning. And finally, our smiley face icon in green, the arrow representing the passage of time, represents attitude. So we'd like students to come to the realization that maths makes sense. It's worth spending time on, and they can enjoy it and become better at it by persevering. So this links very closely with Carol Dweck's model of the growth mindset, that you're not naturally good or bad at mathematics. If you work hard, if you persevere, then you will become a better mathematician. So our intention by sharing this model with you is that we hope you'll be able to use it in your classroom. You'll be able to have conversations with students about how they might develop these 5 key ingredients to become more successful at mathematics. What we're going to do for the rest of the webinar then is to give you a little bit of a sense of perhaps how this could work in the classroom. We're going to try a couple of tasks from NRICH, and then we're going to reflect using this tool on which strands we might have been developing. So in order to do that, we're going to take you to some problems on the website. Rather than going live to the website, we've got some images here to show you around, to help you navigate later on. This is the homepage of NRICH, which we hope will be very familiar to many of you. As secondary teachers, the best place for you to find yourselves to go to would be the secondary teacher homepage up here in the top, in that green button. Clicking on there will take you to this secondary teacher homepage. just quickly to draw your attention to some of the links there, the top left green image is where you'll find all our curriculum linked resources. Do explore those if you're not familiar with them. That middle top box, if you're particularly interested in encouraging your students to work mathematically, that's where you might go. For today, we're going to actually take you to one of our previous features, which you'll see there, this link. And this takes you to a page that looks like this. Now, this is just the top of the page to give you a sense. We've published many features. Just for information, a feature is a collection of tasks and perhaps an article or two all around a particular theme. It's not going to surprise you to learn that the particular feature we're going to focus on in this afternoon's webinar is the Nurturing Successful Mathematicians feature in the top left there. And clicking on that page will take you to the page for the feature itself. Just as a quick aside, the rope image you see at the top there is a bit of a throwback to the Kilpatrick model that Charlie was outlining earlier. You can see from this image that there are 4 parts to this feature. The top left is a short article, and we'll talk a bit more about that later on this afternoon. And then there are 3 collections of problems. The first task that we're going to work on together is taken from the From Random to Systematic group of tasks, this one here. And so I'm now going to hand back to Charlie and he's going to introduce the task to us.
Thank you, Liz. So we're going to look at an old favorite called M, and M, which stands for mean, median, and mode. If you could click on the next slide, Liz, we could just show everyone what M and M looks like. Students are asked to find sets of 5 positive whole numbers with the following properties: mean is 4, median is 3, mode is 3. I'm aware that many of you may have come across this problem already. It's on our mapping document. If anyone's worked with us before, we might have introduced you to it. So we don't want you to work on a problem you've already seen before. So we've got a variation on it for you today, and a variation which won't take you quite as long. So if you haven't seen this problem before, you may want to come back to it after today. So can we have a look at the problem that we've got lined up for everybody today, Liz? So here we've got set of 5 numbers, and we're asking you to find out what the mode, median, and mean is. And this is a good opportunity for you to use the chat facility. So if you could post in the chat what you think the solution is to the mode, median, and mean, we'll give you a minute or two to work out the solutions and post them. So we're getting lots of 2, 4, 6s in the chat, lots of agreement that the mode is 2, the median is 4, and the mean is 6. So I think we should just move on to the next slide. This is far too easy for most of you. So we've got a follow-up question for you, which is this. If we tell you that the mode is 2, the median is 4, and the mean is 6, of a set of 5 positive whole numbers, can you work out other sets of numbers apart from the one that we gave you earlier? And more importantly, can you work out how many sets there are altogether? Now, we don't want you to type in the content of each set. So please don't add to the chat what each set, which 5 numbers are contained within the set. We'd really quite like you to just post how many sets you think there are altogether. And just to clarify, we're expecting there to just be one mode. So we're not going to include sets which have got 2 modes. And of course, when you say how many sets there are altogether, please include the set of 5 numbers that we gave you in the previous slide. So again, a minute or 2 for you to work back at home or at school where you are, and then post how many sets you think there are. So Danny has posted, I love that none of us match. So you can't all be right. And some people are changing their mind as they're going along. And a whoops. There are lots of 6s. Perhaps 6 is the mode so far. But there are some who are suggesting it's less than 6 and some who are suggesting that it's more than 6. And we're assuming only one mode. I'm not sure I want to come up with a definite solution to this problem, Liz, but could we have a look at the next slide and ask everybody to think about how they might convince each other that they have found all the solutions. So could you now type in the chat either how you would convince your neighbor that you've got the right number of solutions, or how you would hope that your students might convince each other that they've got the right number of solutions. John Mason talks about convincing yourself, convincing a friend, convincing the enemy. So this is a chance to convince your friends. Somebody said, I would like to see the numbers again. Can we go back one slide? So we're looking for 5 positive whole numbers. Mode has got to be 2, median is 4, and the mean is 6. So some people are talking about the middle number having to be a 4, because that's the median. And also talking about needing a couple of 2s, because that's the mode. And because the mean is going to be 6, everything needs to add up to 30. So the last 2 numbers having to add up to 22. And then listing the possibilities. And I think the first one might include the pair 5 and 17, and then maybe 6 and 16, and so on. As Liz was saying, you will be able to access everything that's being posted in the chat. And so don't despair that you don't have the chance to both think, type, and read everything that is being posted at present, because you will be able to go and look at this after the event. So I think I'll stop there, Liz, and pass on to you so that you can start thinking about the work that's been carried out so far and how this links up to the model that we've been talking about.
Thank you very much, Charlie. Yes, so as Charlie says, let's go back to the model. Here are our 5 key ingredients that characterize successful mathematicians once more. What I'm going to do is I'm going to put a poll up on the screen. And we're inviting you, please, to indicate which of the 5 ingredients you feel were part of your experience as you worked on the M, and M task. You can choose more than one option, that's absolutely fine. So if you would be so kind as to fill in that poll, that would be really good. Just a matter of interest, it'll be interesting to see what we all think. Once you've completed the poll, perhaps you could add a little bit more detail on the chat, maybe give a reason as to why you've selected one of the particular ingredient over and above another one, or several of the ingredients. And then once most people have completed the poll, we'll have a look together at the results. Thank you. Thank you to those of you completing the poll. That's really helpful. Remember, it will be interesting to see if you care to share on the chat why you've chosen particular strands, particular ingredients. Thank you. I'll just give you 10 more seconds to complete the poll if you haven't done already. Okay, I'm going to end the poll and then we can have a little look at the results. Hopefully you can see that there. So all 5 strands seem to have been relevant to quite a large extent. It seems that most of you selected reasoning as one of your choices, and I can see from the chat that somebody mentioned that chain of logical thought. Somebody says you can't do this problem without reasoning. That's interesting. Thank you for your contributions on the chat. It's hard to keep track of them all, but as Charlie said, you'll be able to save the chat to read them at your leisure. I did catch one that felt that attitude was important because you need that perseverance to keep going. Thank you all very much. I'm going to stop sharing that now.
Can I chip in, Liz?
Yes, of course.
Somebody has typed in saying, I don't quite understand how the tools and attitude strands might work here. So it seems to me the tool is knowing how to work out a mode, knowing how to work out the median. So when we gave you the first 5 numbers, they weren't in order. So in order to work out the median, you need to put them in order and know that you're choosing the middle number. And so you need to have that tool at your disposal. And to work out the mean, you need to know that you're going to be able, you have to add all the numbers and divide by the number of numbers. So those are the tools that you bring to this problem. When it comes to attitude, Helena has written, attitude is important as one has to believe one can have a decent shot at the challenge. So you want to, here at NRICH, we talk about low threshold, high ceiling tasks. And low threshold meaning you can step into the problem quite easily. It's not too challenging to start with. So we feel it's really important to have accessible starting points, which make children feel positive and feel some sort of success very early on. So I'm hoping that the first problem that we gave you did that. And then it becomes harder. I'm hoping a lot of you felt positive about the experience because you found that most people agreed that with the number of sets that were available, because it confirmed what you thought. So you could imagine in a classroom being reassured about that, and so feeling positive in that way.
Thank you very much, Charlie. I'm so sorry, I forgot to mute myself then. Apologies for the echo that you might have experienced. Sorry, Danny, you brought that up. Thank you for reminding me. Thank you, Charlie, very much. That's really helpful. What we're going to do now is we're going to do a very similar process, have a look at another task and reflect once more on how that task relates to these 5 key ingredients. So I'm going to hand back to Charlie to take us through another task. Thank you, Charlie. I'll mute myself this time.
Okay, so one of the other collections of problems that we published back in June when we created this feature under the broad heading of nurturing successful mathematicians was to produce a set of problems where students had to be thinking about moving from the particular to the general. There were 4 problems, and one that many people who know about NRICH may not have seen is called multiple surprises. So let us show you what that looks like on the site. And you can see here on that there are lots of questions. There's a sort of sequence of questions. And again, capturing the low threshold to high ceiling. So what we're going to do is we're going to go through the questions one at a time, rather than give you all of them to think about all at once. So the problem starts by asking if you can find 3 consecutive numbers where the first number is a multiple of 2, the second is a multiple of 3, and the third is a multiple of 4. And once you've found one set that satisfies that criteria, can you find another set or more than one set? And again, we'd like you to post your suggestions on the chat again. And again, we'll give you a couple of minutes to add your suggestions. it's really nice seeing the comments that are coming in the chat. Some people are giving feedback, especially when I haven't explained the problem carefully enough. So yes, there are times when people are not typing in 3 consecutive numbers. And then some people are typing in really large numbers. That's a nice challenge to be, can you come up with 3 consecutive numbers that satisfy the criteria that nobody else has typed in so far, or that you think no one's likely to type in the near future? So can you come up with sets of 3 numbers, multiples of 2, multiples of 3, multiples of 4, 3 consecutive? And again, the suggestions are flooding in. There isn't enough time to read everything right now, but there will be an opportunity for you to take the text away with you and have a look at later. I wonder, Liz, whether we should list some of the possibilities. If we were in a classroom, then I imagine what we would be doing is bringing all the class together and maybe on the board gathering together some of the sets that have been suggested. So I saw lots of 2, 3, 4s, Liz. And then I also saw 14, 15, 16, and also some 26, 27, 28s. But I also saw some larger numbers. I saw a 50, 51, 52, for example, and 98, 99, 100. We've been practicing writing, and this is a lot better than it was yesterday, believe you me. We will get better over time. This is great. Liz, you've done a fantastic job. Much better. I wasn't trusted to do the writing. Liz is by far. So this is fantastic. Now, in the classroom, we might give students some time to think about, to look at those patterns, to see what they notice, to comment on what they notice, to share insights. And some of you have already been doing that in the chat. And then some of these insights could be then used for the problems that follow. I don't want to take up too much time on that. So I think I'm going to show you which 2 questions follow this first one. But I'm just going to read them out so that you know what they are, but I'm not going to give you time to work on them. So the follow-up question are, what can you come up with 3 consecutive numbers, where the first is a multiple of 3, the second is a multiple of 4, the third is a multiple of 5. And you can imagine students using the insights from discussions on the first problem to help them do this, and the next one where the first is a multiple of 4, second is a multiple of 5, third is a multiple of 6. So you can imagine doing that, but because you're teachers rather than students, we're going to move on at quite a pace. And this time I'm going to give you something slightly harder, a little bit more challenging for you. And this time we're asking you for 5 consecutive numbers. And the first one's going to have to be a multiple of 2, next one's multiple of 3, next one's 4, multiple of 5, and then multiple of 6. So again, just like before, post some suggestions in the chat. And if you're feeling, post some suggestions in the chat, and perhaps post a suggestion that you think nobody else will post in the next minute or 2. So I can see a 782, 783, 784, 785, 786 suggested. When I worked on this problem with another colleague, she set the challenge of asking participants to come up with a set where all 5 numbers were greater than 1,000. So I'll set you the same challenge. I'm sure you're as good as the group that we were working with earlier in the year. So I realized we haven't had very much time to discuss how people are coming up with these numbers. And if we'd gone a little bit slower at the very start, no doubt somebody might have mentioned how significant 12 was when we did the very first problem that had numbers that had to be multiples of 2, 3, and 4. Perhaps somebody would have mentioned lowest common multiples of 2, 3, and 4 being 12. And that idea of lowest common multiples then could be used for the problems that follow. I might have missed it on the chat. I'm looking at Liz and she's nodding. So perhaps somebody has, oh, she's nodding, yeah. So it sounds like people did comment about lowest common multiples. So again, apologies that we're sort of rushing through this because we want to spend a bit of time on the maths. We do also want to spend enough time thinking about the model and give you a chance to then look back at what people have written. These examples that a lot of you are typing in at present with very large numbers, it reminds me of what Tim Rowland talks about when he talks about generic example. The ability of children to come up with examples like this, it seems to us, capture the generality of what is important about the numbers. So it's a way of generalizing, which does, so some of you have been generalizing and using some algebraic notation. It seems to me that somebody, Ana Maria Diaz has written 6002, 6003, 6004, and so on. Without using the algebra, she obviously notices something that is really important about these sets of numbers. And it's captured in that set. So without having to work algebraically, you can still work on the generality. And I think that's what Tim talks about when he talks about generic examples. So maybe last slide, just to show you where this goes to. And again, we're not going to give you a chance to work on this last bit of the problem, but you can see that the final challenge asks for 10 consecutive numbers. And this again captures the low threshold, high ceiling aspect of what we're trying to do at NRICH. But hopefully lots of students, as teachers, we might want students to reflect at the end of a lesson that at the start of the lesson, they possibly found it quite challenging to find 3 consecutive numbers or 3, largish consecutive numbers, where the first was a multiple of 2, the next one was a multiple of 3, last one was a multiple of 4. But by the end of the lesson, they're possibly, after the discussion, going much slower than we've done, they possibly feel reasonably confident about being able to tackle this last problem, which they could not have, well, they might not have felt confident about doing at the beginning of the lesson. So when we talk about productive disposition, and I know Liz is going to get you to think about it in a minute, this idea that actually we've made some progress in terms of our capabilities of working and being able to now tackle something a lot harder using the insights that we've developed from working on the earlier questions feels genuinely mathematical and a powerful way of working, and captures what we're trying to do with many NRICH problems. So I'm going to pass on to Liz, who's going to get you to reflect on how this problem links to the model that we've been introducing.
Thanks very much, Charlie. Yes, let's return again to the 5 key ingredients and the student-friendly model that we've developed based on Kilpatrick's. I'm going to show you the same poll it's just telling me whether I want to clear the existing one. Yes, I do want to clear the existing one. Good. Hopefully you can see a new poll there. So reflecting on our experiences of working on multiple surprises, that last task, could you indicate here which of these 5 ingredients you felt were part of your experience in particular? This time in the chat, you might like to suggest what students might, the kind of reflections that students might have if they were asked to think about these 5 strands, having completed the task themselves. Charlie, is your microphone on, or are we okay?
My microphone is off. I think
Great.
that is the air conditioning. Oh. Sorry, I think that's the air conditioning in the building, Liz.
Okay, that's good to know. Great, thank you very much for completing the poll. Do post any reflections that you think students might come up with if they were completing a similar exercise, reflecting on their experience of these 5 different strands using the multiple surprises task. Okay, I'm going to end the poll there. Thank you very much indeed. Let's have a little look at the results briefly. This time I would say that the 5 strands are perhaps more comparable with each other than the last task. Thank you for the few comments that you've put on the chat. Let me have a little. Attitude is central, says Carla, because many will feel discouraged depending on the strategy they've used. Yes, and so I guess it's up to us as facilitators, as teachers in the classroom, to be that encouraging force, to offer ways of becoming more resilient as you work on mathematical problems. I agree, Carla.
Can I just add, Liz? Yeah, I mean, we worked on the problem very fast, and of course, in a classroom, we would use some time after the very first problem to get people thinking about maybe the number 12 and why that 12 was significant. And then when they worked on multiples of 3, 4, 5, and then 4, 5, 6, why we then got numbers that differed by, sets of numbers that differed by 60, for example, and so on. So there would have been much more time to think about what was happening before introducing students to the harder questions.
Thanks, Charlie. So what we're going to do now is we're going to just take you back to the feature page, which we looked at earlier. We wanted to draw your attention, I mentioned that we'd come back to it, to the article that we've published within this feature, written for teachers and parents. So it's this top left link. Clicking that will take you to the article itself, which looks something like this. Do be aware that the full reference for the Kilpatrick rope model is right at the bottom there, but we wanted to share with you our self-assessment tool that we've developed, which you can find using this link. This takes you to another page on the site, which offers some different downloadable resources, which we hope you might find useful. You could print off some of these sheets and use them with students to facilitate some reflection themselves, some self-assessment perhaps, perhaps before they've even started an episode of learning, or once they have tackled some problems. Just to give you a little bit more of a flavour, we've picked one of those downloadable sheets here. And so, for example, before working on the, oops, what have I done there? I didn't want to do that. Before working on the, oh dear, I clicked something that I didn't want to do. Let me check, have I got a pen? Yes, I have. Before working on perhaps an area of the curriculum, such as some area around lowest common multiples, you might invite your students to use this sheet. And as a student in a situation, I might think, well, I'm not really sure I know very much about lowest common multiples. This is not something I'm very happy with, so I might just colour in one square of the understanding stretch. However, I quite like it. I quite enjoy working on mathematics. So, you know, I'm up for a bit of a challenge, but I'm not at all confident with my reasoning. And then, having done a series of tasks, for example, multiple surprises, you might then invite students to use a different colour pen. Let's choose a red for contrast. Oh, okay, so working on that problem has really developed my understanding. I see now, I'm going to colour in a few more of these boxes. I'm also quite aware that I was able to fluently calculate, to fluently find these examples. I was using some of the tools in my toolbox. So let's colour in a few of those squares. And I was given the opportunity to explain my thinking to my neighbour. So I feel pretty good about that. And it's just made me love maths even more. And what you could do is you could join up the outside boxes of your, I failed to fill in any problem solving ones, but never mind, to create a polygon shape. And this could give you a snapshot in time of where students have assessed themselves in terms of the development of these 5 key ingredients. Now, of course, we're offering you just one way of using these sheets. You'll have your own ideas. We don't want to be too prescriptive. But as we come now towards the end of our webinar and our time together, what we'd really urge you to do is to share anything you do if you're on Twitter using the hashtag NRICH Live, and we can carry on the conversation via Twitter and keep that alive. As you've seen, you know how to access the resources on NRICH, so do explore the other parts of the feature further. If you would like to keep up to date with everything NRICH, then Twitter is one of the best places to do it. Our handle is @NRICHMaths. Also, if you are not already subscribed to our email newsletter, you may well like to join up. We send a message once every half term or so. We've really appreciated your participation. It is wonderful to see the comments coming in, to know you're out there, even if we can't see you. As promised, you will be able to download a PDF of these slides from that link there, enrich.maths.org/14759. We will also put up a recording of this webinar, but we won't do that until later in the week at the earliest. Finally, we're very grateful to Trinity College here in Cambridge for providing the funding to rerun the successful webinar we had in June. Perhaps some of you weren't able to make it then and have come today as a result of this. We would very much appreciate your feedback, please, so that we can let Trinity know and we can do better next time. I'm going to post this link in the chat before we close the meeting so that you could click straight away and complete that feedback form. I'll say goodbye for now, and I'll hand over to Charlie again to say goodbye as well. Thank you ever so much for your participation.
Yes, it's been great working with you. I'm sorry it was all a little bit rushed, but hopefully it's given you a flavor of what we've been working on recently. And you'll be able to go back to that feature that we published in June and take look at the resources in your own time. So, like Liz, I'll also say goodbye. And for everybody in Latin America, adiós, ha sido un placer. Bye bye.